We will continue to our conference with Dr. Mariana Carneiro by the title of Reusing Effluents from Agriculture to Unlock the Potential of Microalgae.
Hi, good morning everyone. I would like to start by extending my sentiments to all of the families that were directly or indirectly affected by the recent events, and hope that we can overcome this with compassion and humanity. And I would also like to thank Berat and all of his team for organizing and keeping this conference, which I'm sure took more than twice of the effort than under normal conditions. So thank you very much and congratulations on the great work. So I'm Mariana, I'm from Necton. For those of you who don't know, Necton is a microalgae producing company in Portugal, which has been working in microalgae production officially since 1997. And I'm here on behalf of Necton to present the project REALM, which stands for Reusing Effluents from Agriculture to Unlock the Potential of Microalgae. So, before I begin, I would also like to call your attention to the news you probably received throughout the summer of 2022 regarding the water scarcity that has been felt all over Europe and also around the world. And besides water scarcity, there's also the issue of water quality. European waters remain under pressure from a huge range of human activities that lead to poor chemical status and thus failure to achieve the legislation requirements. In Europe, agriculture is the main cause of failure to achieve good chemical status due to diffuse pollution from nitrates and pesticides that leach to groundwater and thus lead to this failure to achieve the required legislation. In addition, agriculture is also the main responsible for failure to achieve good quantitative status, as it affects also over 18% of the area of groundwater bodies all over Europe. You can also see here several European countries which have nitrate concentrations higher than the legislation, which is 50 milligrams per liter of nitrates. However, farmers have been trying to improve their sustainability, and one of those options is soilless farming. Soilless farming can help to increase crop productivity and valorize the drain water and reduce the environmental impact according to the method chosen. However, it does require good water quality and unfortunately it's not always economically viable. With more than 13,000 hectares of hydroponic cultivation, Netherlands is a great example of this adoption of this method. And we can also see a great need to improve in Almeria, where you can find the greatest concentration of greenhouses in the world, and therefore a great demand for water, fresh water. So urban wastewater directives and national directive has also been improving the water quality all over Europe. However, there is still room to improve, especially in water management and also in the sustainability of the horticultural model. In addition, recent European communications have also led to us to expect an increase in the limitations of the rejection of this drain water and also a decrease in the legal limit of discharge of nitrogen and phosphorus of these waters. So in this sense, we started a proof of concept project, Algae Cycle, which aims to turn waste into value. We thought of doing this project by growing microalgae in drain water rich with nitrogen and phosphorus, leading to clean water and microalgae biomass, which then could be valorized into products such as biostimulants for agriculture and aquafeeds for aquaculture. Results were quite promising. Here on the left, you can see the inoculation of one of Necton's tubular photobioreactors. This is a video, but I don't think it's going to show. I'm sorry, but it's the reactor is a 19 cubic meter reactor filled with rainwater from hydroponic cultivation and is being inoculated with Synadesmus. You can also see it grew quite well. here in green. And in orange, you can also see the nitrate concentration decreasing since inoculation in just 4 days below the legal limit, and after a week, it reached 0. So with this project and also other projects such as Nordaqua, which I think we will be hearing about in the afternoon by SEMA, so an idea came up. We have, on one hand, the excess nutrients from rainwater of soilless cultivation that need to be removed before discharge. Future policies will be stricter and based on a more sustainable horticultural cultivation methods. And closed systems require water treatment to prevent lower crop diseases and lower crop development and diseases. On the other hand, we have microalgae, which are growing exponentially feedstock for many applications, as we saw in this last day. And as we saw yesterday as well, there is an expected increase in demand for algae-based and algae products in Europe. And algae can also help to treat several types of wastewater. However, applications are still limited by high production prices. And of course, water-related activities need to adjust to a more circular economy approaches. And so Realm was born last year in July 2022 in the Horizon Europe call of unlocking the potential of microalgae. So the concept is based on a decentralized production, much like in the milk industry, where you have milk being transported to a centralized processing facility. So in this case, we would produce the microalgae next to key inputs of water and nutrients next to greenhouses at a low cost and using an automatic operation. And then this biomass would be transported to a centralized processing facility based on a multi-product biorefinery to develop products for both aquaculture and agriculture to valorize the biomass. The concept will be tested in 2 validation facilities using tubular photobioreactors in Finland and the Netherlands, and in 2 demonstration facilities in the south of Spain and Portugal by using raceway ponds. Of course, to do this, we have to have an amazing and diverse consortium. Hopefully, I think we do. We have universities such as Almeria, Wageningen, Cádiz, Turku, and Twente, and also non-profit organizations like One Planet, Green Collab, ESCI, IMEC, and S2 Aqua Collab, and also companies like BioHorizon, Necton, Grupo La Canha, the Cerna, FICOWorks, and Ubel Verde. So I'll briefly go over the work plan of Realm, starting with the technical work packages, namely Work Package 2, which is focused on the drain water characterization and microalgae optimization. So since we have such a diverse testing in different places and different crops, we have to characterize the drain water and optimize the medium as it needs any addition of any nutrient, for example, and also determine the best strains in terms of growth, nutrient uptake, and metabolite productivity. This is an example of one of the bioprospecting of microalgae from inside the greenhouse, where you can find a great diversity of microalgae, from chlorophytes to diatoms and cyanobacteria as well. And of course, then we have to optimize their growth and the metabolite productivity. Work Package 3 is focused on technology optimization by optimizing different technologies related to the cultivation systems we will employ, such as raceway ponds and tubular photobioreactors. And in addition, we will also make a very big use of big data and deep learning tools to analyze, predict, and optimize the microalgae production to improve the productivities. Work Package 4 is focused on the validation and demonstration installation. And as I mentioned before, we'll have 2 in the north of Europe, in Finland and the Netherlands, and 2 demonstration facilities in Spain and Portugal using raceway ponds. And here we'll also optimize the harvesting, storage, and transport logistics to the centralized processing facility to increase sustainability and reduce costs. Here we have the example of one of the demonstration facilities, namely Necton. This is the plan. Here you can see a Google Maps picture of the south of Portugal, where you can find Necton near the Ria Formosa. And 20 kilometers away, we have the greenhouse with the berry hydroponic cultivation, where the decentralized production facility will take place, and then it will be transported back to Necton that will serve as a centralized processing facility. So in work package 5, we have, of course, the product development based on a multi-product biorefinery for both aquaculture and agriculture. In aquaculture, we aim to develop products for bivalves, such as oysters and clams, and white-legged shrimp, as well as finfish larvae, while for agriculture, we aim to produce biostimulants and biopesticides with a special focus on tomatoes, cucumbers, and berries. Work package 6 is a must, of course. Here we want to understand the economic, environmental, and societal impacts of the project and determine if REALM is effectively cost-effective. And of course, then we have work package 7 for dissemination and also to develop a business model for any interesting stakeholder to apply the project. So we have different outcomes. We expect to reach below the legal limit of nitrates in the drain water, which is 15 milligrams of liter, nitrogen, not nitrate. Develop more than 8 new products for agriculture and aquaculture. Capture CO2 directly from the air. This will be accomplished in the validation facilities by using a direct air capture technology. Reduce freshwater consumption not only in microalgae production but also in the agriculture facility, in the greenhouse facility. Reduce at least the 50% energy consumption and production costs of microalgae production while increasing biomass productivity. And as I mentioned before, develop the business model for application of any interested party. Of course, overall, we also aim to reduce several technical bottlenecks of algae cultivation while providing the environmental benefits and risks of microalgae production while supporting a better management of natural resources. And I want to make a small note that this is, I think it's a clear example of the application of all of the work that you have been doing. So we normally have very different and specialized studies, and this is the result and the application of those hard-working years that in the end lead to the application at this scale. Of course, this is, sorry, there are some pictures missing. This could not be accomplished without the effort of many people. And we are also open to receive any collaboration if you so wish. You can follow us in our website or in the social media if you are interested, and feel free to contact for any question you have. Thank you.
Thank you, sorry. Thank you, Mariana, for this interesting talk. I have a quick question regarding the nitrate issue, because we had a similar project over the last 2.5 years with a wastewater municipal plant in the neighborhood, agriculture land, lots of nitrate inside from farming. And we could use the algae growing there perfectly for cultivation of plants. That worked nicely. But getting to really low nitrate amounts of the final water, as you were saying, 50 milligrams per liter, less than, we never succeeded that. So are you really optimistic that you can reach that? Because it's really a big challenge, I would guess.
It is. I think it is a challenge, and I don't think we would also put this up together unless we had previous knowledge that this could work. With the project that I showed, Algae Cycle, and also Nord Aqua from the University of Turku, I think we can achieve that. Of course, we are in this project aiming for continuous cultivation, but I believe that for the final achievement of below the legal limit in 15 milligrams per liter, we will need to do a small batch to really reach. But as I showed in the tubular photobioreactor, we could do it. Now we just have to repeat it, which is always, sometimes in science is always the true test. You know, repeat it and see if it does the same. But I think we can do it.
Mariana, I'm going to ask a naive question. I'm not really familiar with the hydroponic system. Normally, the benefits of the hydroponic system must be it's a closed system, so there should not be too much nutrients you would expect, because you know how much nutrients are uptaken by whatever the crop that has been produced. How come there are really a lot of excess nutrients in a hydroponic system? Are they put excessively, or what is the main reason?
That's a very interesting question, and this is something that I've also been learning from, because I have no experience in agriculture other than my garden. But now that I've dwelled a little bit deeper into the topic, I noticed that there are many types of hydroponic cultivation. There are closed systems, semi-open, and there is a limit to the water that you can recirculate, because water starts to get higher salinity, higher conductivity, then you risk the crops. And in addition, there's also the differences between countries. For example, even Portugal and Spain are extremely different in the way they operate. For example, I think Spain is more conservative and actually adds more, they don't want to risk the crop, so they can add more water than needed just to make sure that everything will be okay. And in fact, we can see a very high nutrient content there. And for example, in Wageningen, in the Netherlands, there is, this is a very hot topic, so to say, and they are much more close. They have a much more close system than, for example, in Portugal or Spain. So there are many differences in Europe, but we can find really high nitrate concentration. Sometimes phosphate can vary a lot, and it also depends on the crops and the stage of the crop. So we have a lot of variability here, but at the end they cannot recirculate it eternally, and agriculture is one of the main consumers of fresh water in many countries. So I don't think it will be an issue of lack of water and nutrients.
And a very minor question also, is there anything, you haven't of course probably start characterizing the rainwater yet, but is there any, do you expect any contaminants or toxic compounds that might interfere with algae growth, like insects? I mean, I'm assuming most of them is like organic farming still, but maybe insects, anything that might interfere, like any herbicides or something, you know, biofilm preventers. Do you expect anything like those?
Yes, we have started to characterize the rainwater, and we see many things, algae as well, and rotifers as well. And we'll probably also see several biopesticides, for example, that will cross over to the cultivation. But that is what we will test as well, is the pre-treatment that we need to do to the water, if we need to filtrate it or chlorinate it, for example. And regarding the pesticides, we will also see, because there are already several studies that showed that they can be degraded by microalgae or uptaken. So we'll see what is the case here and act accordingly.
Yeah, looking forward to seeing the results.
Thank you.
Thank you for your presentation, Dr. Mariana.